Welcome to Week 3 of Embryology. Week 3 is frequently referred to as the Week of Threes, as the two-layered embryo from Week 2 will convert itself into a trilaminar embryonic disc during a process called gastrulation. The newly formed trilaminar embryo consists of three definitive germ layers, the ectoderm, mesoderm, and endoderm. It is also during Week 3 that the body axes are established, those being the cranial-caudal axis, dorsal ventral axis, medial lateral axis, and the right and left axis. Let's start our discussion by identifying each of the germ layers and naming some of the tissues and organs to which each gives rise. We'll then move on to how each germ layer is actually formed. The outside layer that is in contact with the cells of the amnion is the ectoderm. The most important derivatives of this germ layer are the central and peripheral nervous systems. Ectoderm also gives rise to the epidermis of the skin and its appendages, i.e. the nails, sweat glands, mammary glands, and tooth enamel. The ectoderm also gives rise to the anterior lobe of the pituitary gland. The middle layer of the developing embryo is the mesoderm. This germ layer gives rise to muscle and connective tissues, including blood and bone. As a consequence, most of the body organs are formed from this layer. Notice that this illustration labels it as embryonic mesoderm to differentiate it from the extraembryonic mesoderm previously discussed during Week 2 of development. The inner layer, or that which is in contact with the yolk sac, is the endoderm. This layer is the source of epithelial linings of the respiratory, gastrointestinal, and urinary tracts. It also forms the epithelial portions of many organs and glands. Gastrulation is the process by which the two-layered embryo is converted into a three-layered embryo and begins with the formation of the primitive streak within the epiblast. Before explaining what this is, let's make sure you understand the picture that we are looking at. The picture in the background is of the same cross-sectional view that we've always been looking at, displaying the epiblast and the hypoblast and the two cavities associated with those layers. The picture in the foreground has the same section. However, the roof of the amniotic cavity has also been removed so that we are looking down onto the bilaminar embryonic disc and specifically the cells of the epiblast layer. So the process of gastrulation begins with the formation of the primitive streak within the epiblast. It forms at the future caudal or tail end of the embryo and is clearly visible in a 15 to 16 day embryo as a narrow groove with slightly bulging regions on either side. The cranial end of the primitive groove terminates as a large pit surrounded by a rounded primitive node of epiblast cells. Formation of the primitive streak is the first structure that defines the body axes. The primitive pit points toward the cranial end of the embryo, whereas the caudal end is going to be just the opposite side. Assuming that the bilaminar disc is viewed looking down at it from inside the amniotic cavity, with its cranial end up, what lies to the right of the primitive streak represents the right side, and what lies to the left side represents the left side of the embryo. The dorsal ventral axis is also defined, with the dorsal side being what faces us and the ventral side being that which faces the hypoblast. We return to a cross-sectional view of the embryo to discuss the process of gastrulation. Let's first look at the picture on the left. During gastrulation, cells of the epiblast proliferate and migrate toward the primitive streak. Here, they detach from the epiblast, slip beneath it through the primitive groove and pit, and spread laterally and cranially. Ingressing epiblast cells move into the underlying layer of hypoblast cells and push them to the side. Thereby displacing them from the future embryo entirely. This is important in that the hypoblast cells do not contribute to the formation of the embryo. Rather, it is the newly placed epiblast cells in this layer that contribute to formation of the embryo. These cells become one of the three definitive germ layers, the endoderm. Once the endoderm layer has been established, there is a second wave of ingressing epiblast cells. That spread between the newly formed endoderm and the overlying epiblast. These cells form the mesoderm. Epiblast cells that do not ingress during gastrulation and instead remain on the dorsal surface of the embryonic disc form the ectoderm. In this image, we see the depiction of the mesodermal cells migrating both laterally and cranially between the ectodermal and endodermal layers as the three-layered embryo is formed. The mesoderm completely spreads between the two layers with exception to two locations in which it is absent. This occurs cranially at the oropharyngeal, otherwise referred to as the buccopharyngeal membrane, and caudally at the cloacal membrane. Both midline membranes are sites where the overlying ectoderm is tightly fused to the endoderm. The buccopharyngeal membrane represents the future opening of the oral cavity. The cloacal membrane marks the site of the future distal end of the gastrointestinal and the genitourinary tracts. Beginning at day 18, the primitive streak begins to regress back towards the caudal end of the embryo. And we see more occurring with each subsequent day of development. As the primitive streak regresses, the remaining portion continues to be active and strings out new cells represented by each of the three germ layers. The primitive streak will continue to supply new cells at the caudal end of the embryo through the remainder of the 4th week, at which time it regresses and disappears. It is important to realize that as new cells are added at the caudal end of the embryo, cells in the cranial end that migrated through the primitive streak at the onset of gastrulation are already beginning to differentiate. This can be observed by the increasing length of the neural plate and groove, which are structures we will talk about in the next video. So here's the neural plate expanding as the primitive streak is regressing. The take-home message is that there is a cranial-caudal gradient of development that persists throughout the embryonic period, meaning that the cranial end is usually about a day or two more developmentally advanced than the caudal end. Sometimes remnants of the regressing primitive streak persist. In these cases, the cluster of pluripotent cells located at the caudal-most end of the embryo continues to proliferate and form a tumor known as a sacrococcygeal teratoma. The word teratoma in general is a term used to describe tumors composed of tissues derived from more than one germ layer. Because of this, they often contain bizarre mixtures of many different tissue types, such as cartilage, muscle, fat, hair, and/or glandular tissues. A sacrococcygeal teratoma is the most common tumor in newborns, occurring with a frequency of 1 in 37,000 births. This concludes week 3 of our lecture series.